To start with, let's get a better understanding of how far our closest neighbor is, and to gauge this, we can use the fastest space apparatus invented by humans, Helios 2, a satellite system dedicated to sun observation. Its speed is 157,000 miles per hour, which is about 0.0 to 3% of the speed of light. Rather impressive. The resources for colonization of the new world are packed, just waiting for the signal to launch. We're heading to the Alpha Centauri system. 3, 2, 1, don't worry, there's nothing wrong with your internet connection. The picture really stays the same. Right now, we're moving faster than anything ever created by humans. But on the cosmic scale, we're practically standing still. We'll be able to reach the nearest star system only in about 18,000 years. That's the reality of things. Only when you realize the scale of these things can you understand how important it is to study our cosmic surroundings. If we ever stand the chance to wake up and enjoy the sunshine from a different sun, the costs are too great to do this at random. That's why Alpha Centauri became one of the first star systems to be studied so closely. People notice the main star, or more precisely, a pair of stars, Alpha Centauri A and Alpha Centauri B. Both stars are sun-like yellow dwarf stars, which appear as a single star to the naked eye. The third brightest star in the night sky captivated the scientists' attention since prehistoric times, including the Summer civilization and the ancient Egyptians. It's even mentioned in the words of Ptolemy, but the systematic scientific study of the star system only started in 1915 when the British astronomer Robert Ennis discovered the third star in Alpha Centauri, a red dwarf that was given the name Proxima Centauri. To this day, it remains the closest known star to the Sun. The open and detailed study of our nearest star happened at the same time as the start of the golden age of science fiction and space opera, which leads to a huge rise in popularity for Alpha Centauri. It has been and continues to appear in the works of sci-fi writers, artists, movie directors, and even music composers. The proximity of another star stirred the minds of creative people from the Strugatsky brothers to James Cameron. Because there in the different world under a different sun could reside and develop entirely new civilizations. And so, Alpha Centauri forever earned its spot in people's minds as the place with the most potential for extraterrestrial life. However, the reality is much grimmer, as it often happens. The active study of exoplanet planted a new seed of hope, discovering a signal or at least circumstantial evidence of life on faraway planets. Scientists found two planets in the habitable zone in the Alpha Centauri system, Centauri AB and Centauri BB. However, unfortunately, after a more detailed study, both planets turned out not to be habitable as we know it. And so, astronomically speaking, these planets were temporarily shut down. But everything radically changed in 2016. After years of intensive search, the scientists managed to find, and more importantly, confirm the existence of an exoplanet in the Alpha Centauri system. What's more, this exoplanet rotates around our closest neighbor, Proxima Centauri. As such, the find was named Proxima Centauri B. The planet is approximately 4.22 light-years away, and it's incredible that it was discovered in the first place, because the planet's mass is only 1.1 times that of Earth's mass. It was a very lengthy and work-intensive process to confirm this existence, which was done by measuring the radial velocity of the planet as it passed across the disk of its parent star, Proxima. But the surprises don't end there. Proxima Centauri B had more surprises in store for researchers. In April and May of 2019, Parkes Observatory in Australia recorded strange radio signals over the course of 30 hours, potentially coming from Proxima Centauri B at the frequency of 982,000.2 MHz. How did the scientists conclude that? Answering this would take us another half an hour, so we'll quote the official statement. The shift in the frequency of the signal matched the orbital movement of Proxima Centauri B, and afterwards, the signal mysteriously vanished. The second attempt to establish connection in 2020 was unsuccessful, and in 2021, it was calculated that the probability of a species being both present in the nearest star system and able to produce radio communication was 10 to the -8, which means the likelihood of the signal being artificially created was extremely low. Additionally, since 2017, the astronomers closely watched for any activity around Proxima Centauri using the radio telescope Atacama Large Millimeter Array. The red dwarf exhibits extraordinary activity, making coronal ejections, these so-called flares. The brightness of one of these flares increased 1,000-fold over 10 seconds, occurring over 2 minutes. Overall, unfortunately, this fact signifies that Proxima Centauri b would be exposed to such a large dose of radiation that any life form would cease to exist, considering that such flares are not uncommon for Proxima. Scientists theorize that any atmosphere that may have existed was destroyed and dispersed into space. The last argument against Proxima b being habitable is the fact that the planet's cycle around its sun is only 5.12 Earth days. Sadly, this means the planet is too close to the star to be hospitable to life forms as we know it. Even a cold star classified as a red dwarf radiates too much heat to sustain water in its liquid form on the surface of the exoplanet. But the discoveries surrounding Proxima don't end there. Using the espresso spectrograph mounted on the Velt, the European Southern Observatory's Very Large Telescope, from 2020 to 2022, the scientists studied the transit of a mysterious very small object, estimated to be smaller than Earth. Eventually, a planet that came to be known as Proxima d was discovered using the method of measuring radial velocity. It's one of the most promising mini-Earths to be studied in the near future. The radius of the planet is estimated to be 0.8 of Earth's radius, while its mass is twice as heavy as the mass of Mars. Scientists have yet to determine the viability of Proxima d as a habitable planet. But if the planet is uninhabitable, what use is that conclusion here on Earth? You've got to look at it from a wider perspective, taking the future into consideration. This discovery shows that our nearest neighboring star system is filled with interesting new worlds accessible for further research and in-depth study. And even if the recently discovered world is not suitable for living, its very existence suggests there are plenty of other exoplanets beyond the current scope of what we can see. What do we mean when we talk about the current scope of discovery? As of today, we only have two main methods of searching for such exoplanet. The most commonly used is the transit method, whereupon the telescope observes the stars for extended periods of time to detect small, but regular changes in their brightness. These changes signify that a planet moves along an orbit between us, the observers, and the star. The other, more complex method is known as the Doppler spectroscopy, also known as the radial velocity method or the wobble method. When two large celestial objects, such as a star and a planet, are interconnected by gravity, it doesn't look like one object spinning around another like a ball on a string. Instead, they both rotate around a mutual center of mass, also known as a barycenter. For example, the barycenter of the solar system is located just beyond the surface of the sun. It makes the sun wobble in place, which, in turn, affects the amount of light that reaches our planet, in effect known as the Doppler shift. As the star gets further from us, the length of the light wave is increased, and as it's moving towards the observer, the length decreases. The astronomers can search for the regular Doppler shift occurrences to conclude the existence or absence of an exoplanet. These methods are fairly effective when we search for large exoplanet. A large celestial body blocks more starlight or causes a larger wobble. But discovering objects such as Proxima Centauri b is much more difficult. These numbers speak for themselves as of today. Only 36 planets out of 32,073 registered in the NASA Exoplanet Archive have a smaller mass than Earth. We only see the giants, which are usually less habitable than the compact mini-Earths. So, what needs to change in the near future? The astronomy scientists have an assured answer: James Webb, the brand new space telescope, the launch of which was observed by the entire scientific community as well as anyone who cares about astronomy. It has the potential to revolutionize our understanding not only of astronomy, but the way the world works as a whole, as well as detecting and studying the light from the very first galaxies. One of the most important tasks faced by the telescope crew is the search for habitable exoplanets. The image captured by James Webb should be so detailed that we'll be able to detect the presence or absence of atmosphere on Proxima Centauri b. Because if the planet has an atmosphere, its winds will redistribute the heat to the cool side of the planet. As such, it will be possible to measure how much heat the planet radiates in an infrared range. As the planet moves along its orbit, we will mostly have the view of its cool side, depending on the way it's positioned. If the planet has an atmosphere, the heat will be distributed more evenly, and there will be less fluctuation of heat along the orbit. On the other hand, if the planet doesn't have an atmosphere, then the heat exuded in our direction will fluctuate dramatically as the planet moves. In other words, for the first time in astronomy history, we have a chance to directly observe the planets beyond the solar system. This opens a whole world of opportunities. We'll be able to not only detect the existence of an atmosphere, but its exact components. For example, the presence of ozone because it would absorb some of the frequencies of infrared light waves, leaving distinct gaps or lines in the spectrum. James Webb can record these. Let's say that a hypothetical alien civilization observing Earth discovers distinct ozone lines in the Earth spectrum, which would enable them to conclude we have an ozone layer and subsequently, oxygen, which makes life possible. We could make the same conclusion. Furthermore, James Webb can determine the axial tilt of a planet as well as its size relative to the size of the star. All of these are very important parameters, which we'll learn to apply in the future. When the Space Telescope fully begins its mission in Lagrange point L2 in the summer of 2022. In the meantime, the telescope is being calibrated and prepared for the initial observation before uncovering the deepest secrets of our universe. When we talk about JUICE, we're talking about the imminent future of studying exoplanet. But what if we look a little bit further? What awaits us in a more distant but already foreseeable future? Travel to these new worlds, of course, only in sci-fi spaceships as they move through space using hyperspace engines and warp drives. Breakthrough Starshot is an innovative project aimed at creating spaceships with a light sail capable of reaching the Alpha Centauri system in 20 to 30 years. By reaching the speed equal to 15 or 20% of the speed of light, thanks to super powerful lasers. This initiative attracted the attention of many space enthusiasts, including the founder of Facebook, Mark Zuckerberg. This project involves several stages, the first one of which is taking the base ship to the orbit, which will then get a number of smaller space equipment to orbit. The second stage is the most challenging, creating an entire forest of super powerful lasers located around the world to enable the constant acceleration of the equipment due to the Earth's rotation. Each piece of equipment, 4 by 4 meters in size, would be targeted by several lasers as powerful as 1 terawatt-hour. That's quite a lot, considering that the mining of all existing cryptocurrency takes 121 terawatt-hours every year. Altogether, the project founders Yuri Milner and the late Stephen Hawking plan to send 1,000 items of equipment to Alpha Centauri. And even then, the estimated cost of the project is suspiciously optimistic. Only $5 to $10 billion, considering the creation of James Webb taking $10 billion. The value of these projects to science is certainly comparable, if not the same. Just imagine if we could send the probes to the stars. That could become the penultimate stage in preparation for colonizing the faraway worlds. This would allow humanity to receive sufficient information about the worlds we may plan to visit in the near future. It could also answer that most essential question: how many worlds are there and how likely is the existence of life out there? Life as we know it, not to mention the more exotic options like those science fiction authors love to invent. Finally, we want to discuss the potential non-standard life forms we might encounter on an exoplanet. Remember how mid-video we mentioned that Proxima Centauri is a rather temperamental star which flares up every 10 to 30 hours, showering the exoplanet Proxima B with abrasive rays, incredible amounts of radiation, and other treats. These conditions are deadly to practically any life form on Earth, but the hope to encounter aliens lives on. Theoretically, life on Proxima Centauri B is possible even taking into account the massive burst of radiation. Some living beings are able to hide from the deadly UV radiation. Aliens, or at least their single-cell forms, may exist under the planet's surface or deep in the water, taking cover in natural hiding spaces. Additionally, the process of UV absorption by proteins that's not been fully studied yet, which once again in theory allows us to speculate that organisms that possess these protective proteins can convert the UV radiation into biofluorescent radiation with a different wave frequency. Roughly speaking, we could dig down a few feet below the surface of Proxima B and discover an entire civilization of glowing biofluorescent creatures. Let's take Earth as an example. As you come down to the bottom of the ocean, you discover that some types of coral polyps contain fluorescent proteins which are photoactivated when exposed to UV radiation in the long-wave range and wavelengths of 315 to 40 nanometers and in the blue regions.